Okay, boys and girls, welcome to 6.6, the trigonometry of right triangles. This will be day number 1. In day 1 video, you're going to see how to label a right triangle. You will also get a refresher on Sohcahtoa, and we will do one problem involving finding some missing angles, sides of right triangles, and we'll kind of go from there. Okay, so all about right triangles today. Hopefully you remember Sohcahtoa, and let's get started. So looking at the first slide that I have in front of me, it says to label the triangle's sides, opposite, adjacent, and hypotenuse according to the angle alpha. So that means I'm starting from this angle right here. Not starting from beta, starting from alpha. So if I'm starting from alpha, I know that the side there would be opposite alpha. This would be adjacent to alpha. Adjacent means right next to it. And the other one would be the hypotenuse. Probably something I'd write in my notes is that the hypotenuse, A, is always the longest side, and B is always opposite the right angle. Okay, so very important that you remember that is where the hypotenuse is located as we keep going. So let's review this thing called Sohcahtoa, right? Sohcahtoa. It's probably one of the most famous acronyms that you have there to remember. So Sohcahtoa, what does it mean? Mnemonic device, how do you remember it? So Sohcahtoa, there is your Sohcahtoa. So S-O-H stands for the sign is opposite over hypotenuse. The C-A-H in Sohcahtoa, cosine, is the adjacent over the hypotenuse. And obviously the tangent is opposite over adjacent. You can see the three trig identities on the right-hand side there. I put them there for a reason. The reason that I put them there is that they are inverses of each other. Holy crap, is it going to be important that you know as we keep going from here and we get into some pop quizzes. I will ask you, what is the inverse of the sine? What is the inverse of the cosine? What is the inverse of the tangent? So understand that sine and cosecant are inverses. Cosine and secant are inverses. Tangent, cotangent, those are inverses of each other. Very, very, very important that you understand that. If I understand that they are inverses, as long as I know Sohcahtoa, watch this. I know that what's going to happen to get my cosecant then, I just simply flip the sign. Sine is opposite over hypotenuse. That means cosecant is hypotenuse over opposite. And you're just going to do the same thing for the other two. So as long as you know Sohcahtoa and know which ones are inverses of each other, you should be able to figure out then quickly what the other three trig identities are. So understand Sohcahtoa, inverse, voila, got it. Okay, let's practice a problem. Okay, oh boy. So I say to you, given that the sine of theta is 4/7, I ask you to find the values of the other remaining trig functions. So that means find the values of the other 5 of them. Well, here's where I'm going to start. I know the sine is the opposite over the hypotenuse, so I know the opposite side is 4. I know the hypotenuse is 7. So what I'm going to do is draw my triangle. I'm going to label theta down there. I could have, if I wanted to, put theta up here. Will not matter. So I have my triangle. Theta is there. 4 I put in the opposite. 7 I put in the hypotenuse. So obviously the only thing I need to figure out is the adjacent side. How do I figure out the adjacent side? Well, I know I'm going to use the Pythagorean theorem. Pythagorean theorem says a squared plus b squared equals c squared. Remember that a and b are simply your legs. C is your hypotenuse. A and B, this could be A, This side could be A, or vice versa. This could be B, this could be B. It does not matter how you label them as long as you understand the hypotenuse always needs to be C. So what I'm going to do, I think I'm going to put A squared. I don't know what A is. I decided to use 4 for B, and I know that's equal to 7 squared. Now all I have to do is solve for A. So I think I'm going to take the square root of both sides. So I get A as the square root of 33. So what I like to do from here is to identify what sides I have. I like doing that. It makes my life so much easier. I know the opposite is 4. The adjacent is the square root of 33, and I know the hypotenuse is 7. I'm now ready to run through my other 5 trig functions. So cosine, I know, is adjacent over hypotenuse, so there you see that. Tangent, I know, is opposite over adjacent. Uh-oh, I see a problem. What is the problem that you see with writing 4 over the square root of 33? Well, I know the problem is that I'm not allowed to have square roots in the denominator, so what I need to do is multiply top and bottom by that square root, and voila, no more square root in the denominator. So yes, you must rationalize your denominator. That's what it's called when you get rid of the square root. You're calling it rationalizing your denominator. It's a must. Okay, keep going. Secant. Okay, I know that secant is the inverse of the cosine. So if cosine is root 33 over 7, I know secant is just the reciprocal, which is 7 over root 33, and again, I have to rationalize that denominator. Cosecant, I know, is the inverse of the sine. So if sine is 4/7, cosecant is 7/4. Cotangent, well, now it's the inverse or the reciprocal of the tangent. If the original tangent, here's the advice, look at this. What I did was, that's why I wrote the original down. I know it's 4 over root 33, so to find the inverse, I just simply take the reciprocal of that, which is, voila, root 33 over 4. So, hopefully, so far so good. Remembering, getting a refresher on right triangles, getting a refresher on Sohcahtoa, and then the big one is understanding which trig identities are inverses of each other. Hopefully you got it, and good job.